So today's topic is on multiplying decimals. You learn to know how to do that. You've already probably added and subtracted them, but today something a little bit new. So we're going to learn how to multiply them. I'm going to put a big parentheses out here because I want to put something in there in just a moment. Here's our first problem to look at. 0.03 times 0.2. Okay, 300ths times 2/10. Now, did you notice that I did something differently here from what I did when we were adding and subtracting? Whenever we were adding and subtracting, we always had to do something that I didn't do this time. What is that? Well, you notice that I did not line up the decimal points. Whenever you are multiplying decimals, you do not need to line up the decimal points. Now, sometimes they coincidentally line up, but it's just a coincidence. But whenever you're multiplying them, you do not need to make an effort to line up the decimal points. Decimal points can just fall where they may. We're going to multiply decimals basically the same way that we multiply whole numbers. But before we work this problem and get its decimal answer, I want to work this very same problem using fractions instead. You see, decimals and fractions are really the same thing as each other. They're just a different way of writing the same thing. So I want to find the answer to this problem using fractions before I even try to work it using decimals. You see, this is 300ths. This is 2/10. I could multiply the fraction 300ths times the fraction 2/10, and the answer that I get has got to equal the same answer that we'll have here. Okay? 3 times 2 is 6. 100 times 10 is 1,000. And so the answer to this problem has to be 6 thousandths. And how would you write 6 thousandths? We would write it by putting a 6 in thousandths place. The correct answer is 0.006. Now notice how crooked those decimal points are from each other. When you multiply decimals, this goes into parentheses now, you do not line up the decimal points. That's very important. You do not line up the decimal points. However, here's what you do. In the problem, you count how many digits are on the right side of the decimal point. Well, there's a decimal point, there's a decimal point, and when I count all the digits that are on the right side, there are 1, 2, 3 of them on the right side. And in the answer, there are also that many, 1, 2, 3 of them on the right side of the decimal point. 3 digits on the right in the problem, so there must be 3 digits on the right in the answer. Next example, a little easier, 0.3 times 0.4. Now notice that it was just a coincidence that the decimal points lined up in this problem, but they're still not going to line up with the decimal point in the answer. 4 times 3 is 12. Okay. Now in the problem, there are 2 digits that are on the right side of the point. So in the answer, I have to have a total of 2 digits that are on the right side of the point. Okay. Next example, 0.17 times 0.2. 2 times 7 is 14, carry 1. 2 times 1 is 2, plus the 1 more up here makes 3. Now, in the problem, count. How many digits are on the right side of the decimal points? 1, 2, 3. So in the answer, I also have to have 3 digits on the right side of the decimal point. 1, 2, 3. There have to be 3 digits on the right side of the decimal point. So what does that missing digit have to be? Well, it has to be a 0. 0.034. 34 thousandths. Okay? And let's do one more. Let's do 1.3. Change pins. 1.3 times 25. 5 times 3 is 15, carry 1, 6. Now I want to scoot over a space and multiply by 2. A lot of people like to put a 0 here in this place to help them remember not to put anything there, okay? That when you multiply 2 times 3 and get 6, that 6 isn't going to go here. It's got to go in this space. If you like to put a 0 there, by all means, go ahead and do that. If it helps you to put one there, then go ahead and put a 0 in that space. 2 times 3 is 6. 2 times 1 is 2. And draw a line. I want to add this all together. 5, 12, carry 1, 3. Now, there are a total of, wait a second, that number doesn't look like it has a decimal point. But it does have one. It's just invisible. It's always sitting right after. Remember, the decimal point always comes after 1's place. So in this whole number, the decimal point goes there. Okay. And so there are a total of only one digit. There's only one digit after the decimal point in the problem. So there must be one digit after the decimal point in the answer. And so the answer is 32.5.